Hello everyone. I hope you all are doing fine and in best of your health. It gives me immense pleasure to welcome you all for today's webinar session on behalf of Manufacturing Today magazine and Universal Robotics. Today's topic will be Achieve Manufacturing Excellence with Collaborative Robots. We have the subject matter experts today with us and who are going to answer all of your questions. And I'm sure there will be a lot of learning during this webinar session, which will be helpful for the industry at large. COVID-19 crisis exposes vulnerabilities in the supply chain and productions across the industries. In this time of uncertainty, we have to implement certain productions norms, which are right from health hygiene to the production automation, which will be helpful for us using the collaborative robots or cobots, which we are discussing today, help us keeping the social distancing when it comes to the shop floor. Cobots can be another alternative, keeping in mind the kind of production norms we are facing today in terms of the labor. And I'm sure this new solution will help our factories and our production on a larger front. Before I start, I just wanted to take you through the webinar do's and don'ts. I'm sure you all are aware about this, but there are many new joinees who would like to be known about this. This webinar session will be having, in terms of you want to chat with us, if there is any communication, do write us in the chat box. We will try to solve the inquiry as fast as possible. Further, as the session looks very interesting, you must have seen our topic, during the registration process. I'm sure you will be having many questions to ask the subject matter experts. We encourage you to ask questions. Please do tab in the question tab, which is in your screen. If possible, you can also write the speaker's name. Who would you like to ask the question? And we will try to maximize questions during this session. The question answer round will be at the end of the session before we have the subject matter experts for today who are going to present. There will be a Cobot demo, and there will be also some insights on the manufacturing processes using the Cobots. Before we start, I wanted to give a quick introduction. I won't take much time because I know you guys are all waiting for today's session to maximize your knowledge. Let me take quickly on ITP Media, who we are organizing the session, what we do and what we publish. ITP Media Group is the largest foreign media house headquartered in Dubai. We have been publishing over 100 weekly and monthly magazines with a wide portfolio of leading digital properties. In India, we have published 7 B2B magazines, and we also organize events, conferences, webinars, as well. For your knowledge, we are into various industry verticals. Manufacturing Today is the magazine which is organizing today's webinar session. These are some of the pictorial views of some of our special issues which we have done throughout last 1 year. And Manufacturing Today is a leading industrial magazine. It's a monthly magazine. It leads from the front in terms of the technology, in terms of the product portfolio, in terms of the news, case studies, cover stories, and brings in some of the deep insights on the manufacturing and industry in India. Manufacturing Today also delivers various conferences, key conferences for the industry, and also do the annual Manufacturing Today conference and awards. Today's eminent speakers. We have with us Mr. Pradeep David, who is the General Manager, South Asia Universal Robots. Highly qualified expert in robotics and industrial automation with a master's in robotics, Clemson University, and MBA, Marquette University, USA, and he has over 30 years of experience. Pradeep has worked with Rockwell Automation in the US, Singapore, and India, and now he is based in Bangalore, heading South Asia for Denmark-based Universal Robots. the leading manufacturer of advanced, user-friendly, and lightweight collaborative robotic arms. Our next eminent speaker is Mr. Navneet Kejriwal, who is heading the manufacturing operations for Dell India, and he's also the site head of Chennai manufacturing plant of Dell ICC. Navneet has a leadership role in manufacturing engineering for Dell factories worldwide with a strong focus on lean digitalization of manufacturing operations. Navneet holds 25 years of global experience with multinational companies with, with accomplishment in electronics and automobile industry, spanning supply chain operations and strategy, manufacturing operations and engineering product development, supply chain, quality vendor development. Prior to Dell, Navneet was with NEC for over 12 years, holding various roles and assignments based in US, Japan, and Malaysia. Fluent in Japanese language and culture, Navneet was awarded Manufacturing Technology Fellowship MTF in 1994, jointly by the US Commerce Department and Japanese External Trade Promotion Organization, JETRO, for excellence in manufacturing. Navneet holds a bachelor degree in mechanical engineer from IIT Kanpur, India, and a master's degree in industrial engineering from Louisiana State University, USA. I'll hand it over to Pradeep to start the session with his presentation. Over to you, Pradeep.
Sure. Thank you, Sanjay. And I'd like to start by thanking Mr. Kejriwal, Navneet Kejriwal, for joining us in this session. So very quickly, go ahead and share the screen. And I hope the screen is clear and my voice is audible. Okay, so I'm assuming that it is, and we'll go ahead. So today's topic is about collaborative robots and what they do for manufacturing, right? So I think you're looking at the screen right now and you're seeing various applications. After all, what is a collaborative robot? It's something like a human arm. So just think of it, if you had a third arm, what could you do with it? And that's what a collaborative robot is. Notice that a human being is standing right next to it, no fencing. So it uses up very little space on your shop floor. And the arm comes in different sizes, right? It can carry 3 kilograms or 5 kilograms, 10 kilograms, 16 kilograms, so different sizes. And it's essentially a tool that helps you do your job easier, okay? And once again, you notice the operator sitting right next to it. So if he needs to do some kind of assembly application, let's say, then the robot can feed him the parts or maybe help him with the assembly. So it's really something like an assistant to an operator, all right? So maybe with this one slide, one video, you get an idea of what we're going to talk about. Today is the era of COVID, so I think we can't start any presentation without talking about COVID. So all 4 slides, all 4 windows here, or quadrants, show you the collaborative robots used in the fight against COVID. The first on the top left, you can see in Singapore, it is actually doing a disinfectant job. So if you've got a hospital or your own factory, somebody calls in sick and you want to disinfect, you can just send this AGV, if you would, controlled with a joystick, and it can go and sanitize that place. The top right, it shows how an UV wand is taken, and so let's say that particular operator of that computer had COVID. So you can now remotely send this device there. It's a human arm. It opens the drawer, it cleans, it uses the ultraviolet wand to clean what you need to do, okay? Bottom left, if you had this job of, our poor doctors having to take throat swabs of people who are coughing into their face, and it's pretty dangerous, right? So if any of you have relatives, you know how sad it is for them, their job currently. So this robot actually has a touch sensor, and it can actually go feel the back of your throat and take the swab without putting anybody in danger, okay? And the bottom right, this is a car factory, because I know a lot of car factory people are here today attending. They actually made it into a ventilator facility in Spain. When Spain had a pretty bad situation a few months ago, 1 month ago, a car factory actually Seat became a maker of respirators, okay? The same Cobot that they were using for glue dispensing on the line was taken and used for. So I guess you're getting the idea now a Cobot is really a very flexible tool. It's something pretty handy that you can move around the place, use when you require it, and move it to a different location. Okay. So this was a little bit about COVID just to get started, because that's the era we're in. And some of the benefits of this human arm looking device that we call a Cobot is, number one, social distancing. And that automatically creates space between two operators. I think Mr. Kejriwal will talk a little bit about this. It's also very quick to deploy and redeploy. Okay, so I showed you the example of the respirator maker, how they took a Cobot from the factory. It was doing something else and now moved it to make respirators. Now they moved it back to, let's say it was doing machine tending, right? This is in Chakan in Pune, where one of our customers, L'Oreal, is actually moving the Cobot from place to place, depending on which line he needs to do the palletizing on. Bottom right, it talks about democratized automation. So this is affordable automation, unlike other forms of automation where you have to have a huge budget. The fact that this is affordable, notice that the lady you see there is not like a robot programmer. She's, however, got a teach pendant in her hand. She's programming the Cobot at a small SME. So the point here is we can teach the existing operators how to handle a Cobot. It's that simple. If they know how to handle a cell phone, and all of them are pretty good at cell phones, right? They can handle the Cobot. Okay. And probably the most important benefit, top right, partial automation. So in this day and age where cash flow is an issue, and if you're trying to automate your line or you're trying to automate a cell, and the cost is a few crores, right? And it just goes through an endless cycles of approvals. So what this is doing is, notice there's a human and a robot working together in that particular. I'll show you the video in a minute. But I can remove the cost of automation completely and put a robot and a human to work together, and thereby removing a lot of the cost. Okay, so step by step, I can start automating the facility that I want to do. Okay, so that's another very beautiful advantage of a Cobot where partial automation is supported. So what is the difference between a robot and a Cobot? This one slide, just by looking at this picture, hopefully you can see it, right? Number one, you see the amount of floor space that a robot takes, the amount that is caging around, and therefore that valuable floor space is gone. Okay, you can't enter because robots are known to kill people, right? So on the right-hand side is a Cobot. It's friendly with a human being. He puts it on a trolley, he moves it around from place to place, right? It's flexible to use. So very, very stark, the difference between a robot and a Cobot. Okay, robots have been around since 1961. There's nothing new about them. Cobots are relatively new because the standard that supports Cobots, which is the ISO Technical Specification 15066, it only happened in 2016. So it's not too long ago that Cobots have come into existence. Okay. So with this, I would like to take a short pause and request Aisha to run a quick poll as to how many of you actually use robots today. So Aisha, if you don't mind sharing that first poll. So I think we'll give you a few seconds to answer this question. Let's say 30 seconds. It's a simple question. Are you a robot user? Yes or no? Okay. So I see about 113 participants are there already, but hopefully you all have answered your question. You just have to click, no need to write in the chat box, just click on that. And then we'll share the results with everybody. There we go. It's about 50-50. So no is 60%, let's say 60-40, right? So 60% are not users of robots in any way, which is probably why you're sitting in this presentation, which is good. Right? Hopefully we learn some of the new technologies associated with this. So I'll go back into the presentation now. Thank you for that information. And here's an example of machine tending. Okay, so here's a standard CNC machine, and a collaborative robot is picking up bar stock from an in-feed, and this in-feed could be a conveyor belt, it could be, you know, a matrix. So it's a bar stock, it's measuring the bar stock, and then you notice it's got two grippers. One is for the raw part and one is for the finished part. So typically something like this, if I needed to run in the night shift without an operator present, it's possible to do now because this arm is behaving just like an operator. Yeah. So notice it is removing the machined component and inserting the unmachined component. That's why you got the two grippers. And then it comes out and puts the machine part in the output bin and starts the machine, hits the button to start the machine, and it puts the part there, right? Very simple. It's called machine tending. It can be done at 30 micron repeatability, and very, very standard application with cobots, okay? Machine tending. So unmanned night shift, for an example. In India, very commonly, you will have one robot tending two machines, for the ROI calculations and the cost of our labor, etc. You may have two machines, and I'll show you some videos of that. Okay, so this is a very typical example of a cobot in action, right? Now, you may have seen, stories about, or things in the press about cobots. The silent revolution is taking place in Indian workspaces, etc. So what exactly is happening with cobots? Okay, so when you look at a consultant, Frost and Sullivan, who talks about the top 50 disruptive technologies, we've all heard of 5G and blockchain and AI and all these things, correct? But in the space we're in, bottom left corner, which is advanced manufacturing and automation, you notice that collaborative robots is a very important part of the 50 disruptive technologies. You won't see just regular robots here. Robots have been around for 60 years. But collaborative robots are future-proof, okay? They are actually going to help you as you get back after COVID in the next generation of manufacturing, just like 5G and blockchain and AI, okay? So it's very important, if you haven't started using this technology, you start looking at your competition, looking at what you can do for your customers with this technology, okay? It is part of Industry 4.0. I'm not here to define Industry 4.0. Many consultants have done that, and you've probably seen it. This is McKinsey has defined it in 26 different sectors or levers, as they call it. I'm just interested in one of them, which talks about human-robot collaboration. In other words, when I spend, let's say, about 20 lakhs to put a Cobot into my plant, if I'm SME, let's say, I've just embarked on my journey towards Industry 4.0. And I'm using one of the top 50 disruptive technologies that consultants are talking about to future-proof my factory. Okay. So what is this technology about? Notice that this is an assembly line of the future. Human, robot, human, robot, human, robot. It's not all robots, it's not all humans, but humans and robots working hand in hand with each other. This is an amazing concept because MIT did a study, that's the Massachusetts Institute of Technology out of Boston. They did a study at a BMW plant in South Carolina. So this is in Greenville, Spartanburg, South Carolina. And they did a study where they found that when I have humans and robots working together, there's an 85% reduction in idle time. Okay, so that's not to be sneezed at. Today, with all the problem we have with labor and people who have gone back to their villages and not coming back, 85% reduction in workers' idle time and productivity increases that you get because of that. Okay, so look at this very carefully, because this is what manufacturing is going to look like in the future. Humans and robots working next to each other, hand in hand, and without any cages. Notice there's no cage there because it's safe. These are safe robots. They are patented safety, which allows a human and a robot to work together. Okay. So some of the major benefits you get, number one, it just plugs into the wall, single phase power. I don't need three-phase power for it. It's very simple to program. I talked about a cell phone, right? I'll show you an example how to do it in a little bit. Every axis, and by axis, this is really a 6 degree of freedom articulated arm. Okay, so each of these axes is a motor. It's a little bit more complicated. There's 2 encoders in there, a magnetic encoder and optical encoder. There's a dual safety bus there. So the communication happens between 2 microchips between these, just to make sure that my safety is foolproof, TUV certified, all that. So anyway, each axis can move plus or minus 360. What does that mean to me? Well, it means that I can now operate in a very confined space. It's very dexterous in its movement, and it can reach in very complex positions to the object I'm trying to pick up. Very little power consumption. This talks 350 watts. This is for the 10 kg payload. For the 5 kg payload, it's only 150 watts, nothing more than your light bulb. This picture is from Bajaj Auto. Bajaj has over 100 of our Cobots being used. And they've actually hung it from the ceiling. And you can see there's a little, this is where the engine block comes in. There's a camera here which spots where all the bolts are. And there's a nut runner. And the nut runner automatically, 12 bolts will be tightened. The Newton meters of torque is logged back to the database against the chassis number. So I can get absolute best quality. And I'm not ergonomically taxing the worker. Plus, I'm automatically getting social distancing between two operators. Okay? Many benefits of having a cobot alongside your worker and assembly lines. And of course, this I already showed you where you can move a cobot from one location to the other. Okay? It's not easy. There were 65 patents that allowed us to make this happen. We are one of the pioneers of this. And today, you will not be the guinea pigs. You know, there's 45,000 deployed globally, 45,000. So it's by no means emerging tech. It's really mature technology now. We've been in the business over 10 years, so we know what we're doing on this. By far the leaders in this space of collaborative robots. A few videos I'm going to show you now, and of different things. Top left, again, it's Bajaj. You can see their KTV or whatever motorcycle they're making, and this is the application I showed the picture. It's doing the nut running automatically while she's doing some other work, okay? So humans and robots working together, humans doing the value-added work, the robot doing the brute force, maybe the stuff which is very accurate, which you can't fail, you know. The top right is at a Peugeot factory in France. Notice that it's a pretty complicated one, but it goes under the chassis of the car and does the bolt tightening. You know, in some cases, it'll do the washing of under the car or painting under the car, but in this case, it's bolt tightening, right? So they have a complicated fixture that they've patented. This is Peugeot, PSA. And once they put it on the body of the car, it will go and tighten the bolts underneath, okay? Well, that's big companies like Bajaj and Peugeot. How about little companies? Bottom left, this is in Chakan, Pune. He has only 10 CNC machines, but he can afford to put a simple pedestal like this and put a collaborative robot on it, okay? Because he has labor problems. He has quality issues. In fact, his customer, you know, is very insistent that he better be Industry 4.0 compliant if he wants to keep supplying, okay, to this MNC. Therefore, he is required to increase his productivity, the fact that he's Industry 4.0 compliant. And I know there are food and bev people also attending our webinar today. So here's an example in a small dal manufacturer in Chennai. She used to carry all these packets of dal. Today, the robot, which is hanging upside down from a small frame, and that's called zero footprint. It doesn't use any space on your shop floor, right? It's just packing those things into a plastic bag, and she's just changing the plastic bag as and when one thing gets full, okay? So many, many examples of collaborative robots, okay? We call it the big equalizer. This is not only in the domain of the large companies, even a small company, a small SME can afford this. In fact, take a look at pictures all around India, okay? This guy has about 150 employees, New Engineering Works, who makes parts for Tata's commercial vehicles. You know, this guy makes export parts. He's in Pune. His more expensive parts, maybe he could afford it, but this guy, Shruti, is a very small engineer, you know, or the one on the right, middle bottom, Sai Markers and Engravers. He's a small paint shop, and he found that the quality of his paint was being compromised by operators in the night shift where you don't have much supervision, you know. So he put a Cobot in, his quality went through the roof, okay? His rejects went down. He was able to pay for this within a year. He's putting multiple Cobots in now, okay? So great examples. Krishi irrigation. Recently on CNBC Awaz, this guy makes irrigation valves, and he uses our Cobot. So again, small manufacturer, I just want to show you, can afford this technology. So there's no need to delay. Like I said, in about 20 lakhs, around that range, if you have the budget, you can start with this technology for sure. So a couple of concepts now before I turn it over to Mr. Kejriwal. And that is the concept of partial automation and flexible automation, okay? So in this, there was this article in a magazine about Tesla. You know, Tesla is a famous company with the electric vehicles, and how Tesla shot itself in the foot by trying to hyper-automate its factory. So you do have to be careful. When you try and automate too much, you can go the wrong way. You can actually cause production to go down, which is what happened at Tesla. Okay, they were getting orders of 5,000 vehicles a week, but because of over-automation, and over-automation caused inflexibility. And you know, human beings need a lot of flexibility. You and I now go online, place orders. We want to change it. We want to customize the seat color. We want to customize the way the car is. They could only make 2,000 a week. Okay, so it took a famous guy like Elon Musk, the CEO, to say, he acknowledges that there's an optimal level of automation. And it's a complex balancing act of design, productivity, quality, and human and machine skills. What does that mean? Robots and humans have to work together. You cannot have what's on the left, just only robots and nothing else, okay? Because you lose your flexibility, and many companies have realized that and now are inserting robots and humans working together, just like Tesla has, okay? So this is what we mean by partial automation. Is very important. And this example at a food and bev company shows how partial the robot is actually picking up these bottles or whatever this is. It's collating them, and the man is holding the carton open. Now you may say, why couldn't we have automated that? Certainly we could have automated that, but the cost of my project would just have gone up through the roof, and I'm going to have to wait 6 more months so that I can afford a conveyor belt, a carton erector, all those other kind of automation to support this automation. Cobots say, no, that's not necessary. You want to start today, like I said, approximately 20, 25 lakhs, get started, get this Cobot in, let it do the case filling, let the man be there to do the erection of the box. We can change that later on. So this is a classic example of human and robot working together because this Cobot is safe, okay? So I think it's very important you understand this, because in today's environment where cash is king, and nobody has massive budgets, partial automation will help you do projects, help you get automated, and yet not break your budget that a completely automated solution would do, okay? So partial automation is one concept. Flexible automation is another. In flexible automation, I already talked about how I can take a robot from one location to the other. This is in a cosmetic factory, and they make cosmetics for this company called CoverGirl. So, you know, nail polish and face creams and all kinds of things. Now they have about 12 presses where these powder puffs are made, okay? Now, instead of buying 12 robots for 12 presses, what they decided very smartly to do is, hey, I don't operate these presses all the time. So what I'm going to do is I'm going to buy 2 robots, put it on a mobile cart, and I'm going to go service that particular press, okay? So you'll see this in a second, where a UR5, 5 kilogram, and a UR3 are put on a cart, and they wheel it in to the press where it's needed. So now I don't need to buy 12 robots for 12 presses. I just have 2 of these carts with 4 robots, and I move it to the location I want. All I have to do is locate the cart. So I put a pin on the floor, which locates the entire system. And now I suddenly, with just a few Cobots, okay, and the fact that it's flexible, I can move it around and just plug it in a single phase power to it. It gives me huge amounts of flexibility. So I think at this time, I'd like you to just step back and reconsider. If you have been thinking about robots as those big devices that you buy for one application, let's say I want to do painting, or I want to do machine tending, and that's all it's going to do for the rest of its life. Think again. The Cobot can now help you with your COVID fight, doing something. It can move from machine to machine. If one operator called in sick, I can move to that machine, choose the right program, and have it start working, okay? If my orders go down in one line, I can move the Cobot to another line, okay? So these are the compelling stories of collaborative robots, which a regular robot does not stand a chance of comparing with, okay? Now, this is from a universal robots perspective. I'd like to take a quick break here and turn it over to my fellow panelists. We're very grateful that the manufacturing head of Dell from Chennai is here. And I'll turn it over to Mr. Kejriwal, to give his insight onto his experience with Cobots. Over to you, sir.
Thank you, Mr. Pradeep. Thank you, Sanjay. So it's my pleasure to be here and have a conversation around a very interesting technology that I think has benefited us in our environment. So I'm Navneet. I head the manufacturing operations for Dell. We have a plant in near Chennai, in Sriperumbudur, where we manufacture different computer products. Could be laptop, desktop, and servers. The factory has been operating since 2007, and we pretty much take care of most of the demand in India from this location. This is the only manufacturing plant Dell has in India. This is part of the 10 manufacturing plants Dell has worldwide. So thank you for the opportunity to share some of my perspectives around our experience with collaborative robots and the partnership with UR in our journey. So just to give you a feel of our manufacturing environment, so this is an electronics assembly, test, pack kind of a manufacturing environment. Typically, we do around 1 million units a year. So it's pretty high volume manufacturing environment. And as you may have heard, Dell has a kind of a build to order production model. So we only build when we get the confirmed order from customers. So what that means is basically that we have a variety of orders moving into production all the time. So we need to have in our production systems a high level of flexibility because, as I said, we have different form factors. We have all-in-one computers where your monitors and the computer is all integrated in one device. We also have laptops of different models. So that flexibility to make anything in a production line and have a mixed model kind of a production flow is the core to our manufacturing concept. So we introduced collaborative robots I think about a little over 3 years ago. That's around the time when we were, moving towards a digital and digital transformation in our manufacturing environment. And we had a strategy on 2 pillars. On one hand, it was what we call digitalization. And on the other hand, we had smart automation as the 2 pillars. Initially, we were looking at these 2 as 2 separate pillars. The one on digitalization was focusing more on the information and data aspects. How do we empower our workforce so they have real-time visibility all the way from frontline operators to supervisors at all levels. We wanted to empower people with the right information so that they can make decisions. We can have smart alerts. So a lot of applications and tools were developed to increase the efficiency of humans in making decisions and accessing information. That was our digital strategy. On the other hand, we had a smart automation strategy as well, which was on looking at some of these repetitive tasks, complex tasks, which were difficult to do, and try to do some automation there as well. So of course, as any automation, it is always based on a CapEx investment and there has to be an ROI. But typically the functions tasks that we were identifying in smart automation were those which had ergonomics or repetition and opportunity for some assistance by a machine to a human operator. So we did a complete value stream mapping. And I think if you're familiar with electronics manufacturing, you would know that a lot of the assembly tasks are very delicate. We're handling a lot of sensitive parts. Automation commonly is not that easy in these kind of very delicate assembly tasks. So we tried to identify areas where there was less risk of any damage. So we started with the back end of the process where the computer is already made, tested, and now it's packing. So there we had a task where a human operator has to lift the unit uh, and put the cushions on the two edges and then drop the unit in the box. So typically there were two people doing this task. One was kind of an assistant, very low skill job, very repetitious, and also it involved lifting and some weights. We couldn't deploy women in that task. So we started looking at ways where we could make it more friendly, easier for humans to work with. So that's when UR stepped in and we identified a solution for that. So it was a very interactive kind of a human machine task designed uh, with the collaboration in mind between a human and a machine. So of course, as I said, this was not an easy task because we have a mixed model production line. So you could have a mini tower form factor followed by a small form factor or a micro. So many different form factors flowing into the production line randomly with different configurations. So we had to put intelligence in the solution. So we had to have a system which could recognize the unit which was flowing and accordingly adapt its position and orientation. So we also incorporated a camera, a machine vision solution. And then the other challenge was that end effector. So, not just the hardware, the robot hardware itself, but you have to have the gripper or something which will actually hold the unit in production. So there we had some engineering done. So the whole experience with Cobot, with Universal as a partner was very positive, I believe, because we were all together collaborating and looking at the solution, and not just you are saying that here's my robot, you use it, and it's for you to figure out the solution. So they were with us. We brought in the other vendor who was supplying us the machine vision solution, the hardware, and the team, our engineers worked collaboratively with UR and the other component technology vendors to create a solution. And UR was very patient. They invested a lot of their time. They actually loaned us a sample, a robot, till we had a proof of concept. So all the initial hesitation, skepticism around automation and making an investment, not sure about the ROI, all of those concerns just disappeared once we started working, and eventually we had a POC in the time frame which was beyond our expectations, much faster, much sooner. So our initial experience with UR had been very positive. We created an environment which was very easy for humans to work with. We could, male or female, anybody could take that position of in that production line and help the units getting packed. So very positive feedback from our own employees. Once initially there may have been some concerns around automation, but when they started seeing, the people on the production line started seeing the robot as an assistant, the human is still in the commanding position, and all the difficult part of the work was handed over to the robot, doing very efficiently. The robot is always one step ahead in presenting the unit for the human to do his part or her part in completing that task. So it was a very positive initial deployment. We were very encouraged. So we identified more opportunities to deploy our Cobot. So now we have a second use case also running in production, which is at the beginning of an assembly line where we pick up a chassis or the, as you call the cabinet of a computer from a carton box, bulk carton box on the production floor, and put it on the conveyor line for the assembly to start. So this was also a kind of a complex solution because these units arrive in a multi-layer carton box. So, and then again, it could be a different models, different form factors, sizes. So with an integration of machine vision, this was intelligent enough to identify the orientation, the size of the unit, and also which layer, was it the top layer or the bottom layer. And based on that, the motion of was programmed and automatically selected. So this was also running now for quite some time, and it's proven itself. The thing we like about UR again is very reliable machines. The first use case has been now running for almost 3 years. And I don't remember any single downtime, any single event caused by the Cobot in creating a downtime. Of course, there has to be some preventive maintenance done. And I think UR did a great job in training our own employees. And also keeping stock of some of the spare parts which are prone to wear and tear. So some of these heavy loaded joints where the bearings need to be maintained, replaced. So we have that. So our team is self-sufficient now in doing some of the basic maintenance. But of course, we also have a maintenance agreement with UR, and they're always there to support. So reliability has always been a very positive point that I would say about UR machines. As I said, Dell, this plant is one of the 10 plants we have worldwide, and our accomplishments here were first of its kind in Dell, and our colleagues and my peers in other factories, when they saw this deployment, they got excited. They also, some of the use cases what we did here were replicated in other plants, and some other plants collaborated with UR for new areas, for other areas as well. So it's been very positive for us to engage with UR and and use the technology in solutions which is helping us achieve our goals. Our goals, as I said, is to improve productivity. Productivity, of course, has a justification in terms of financial metrics. So productivity improvements is one. Quality consistency in quality is the other, and also the ergonomics and making it easier for humans in the workplace. So I think it's been a great journey. We are excited. We are looking ahead on where else can we apply the cobots. So I think some of the delicate tasks we talked about, installation of delicate components. It could be a processor or a memory, making some connections. So those areas are also challenging, and we are doing development work there with partnering with UR. So that's all I have to say. I think overall, I would thank David for his personal support to us. It's been a great experience. Thank you.
Thank you, Mr. Kejriwal, and I'm sure there'll be questions for you from the audience. I'll go ahead and share my screen again and just take you through one quick video.
जमशेदपुर में हम लोग 110 सालों से रह रहे हैं। जिस फैक्ट्री में बैठे हैं इसका नाम है न्यू इंजीनियरिंग वर्क्स। ये फैक्ट्री हमने 1996 में खरीदी थी। 2 सालों तक मैंने पर्सनली प्लांट में मशीन चला के सीखा कि क्या प्रोडक्शन होता है, कैसे प्रोडक्शन होता है, और हमारी एम्बिशन यही था कि एक दिन हम भी आज के दिन वर्ल्ड क्लास मैन्युफैक्चरर्स बने। कॉमर्शियल व्हीकल का डिमांड बढ़ते जा रहा है, तो हमने सोचा कि क्यों नहीं टेक्नोलॉजी को हम लोग यूज़ करें और मशीन खरीदने की जगह हम लोग रोबो खरीदें, ताकि हमारा ऑटोमेशन भी हो जाएगा, कॉस्ट पर कंपोनेंट भी कम हो जाएगा और हम 24 आवर्स अपनी मशीन को चालू कर सकते हैं। एक दिन पता चला कि यूनिवर्सल रोबो जो कि ह्यूमन फ्रेंडली है, वो भी एक रोबो है जिसको हम लोग यूज़ कर सकते हैं।
It's been 1.5 years since we've been using UR Cobots, and it's been a great experience for us. I still remember when I saw the Cobot for the first time, I told my dad, this is what we need for our components. We have 2 divisions. We have like a small component division and a big component division. And for the small component division, I think there's no better robot in the country than UR Cobots. When you're an SME, land is extremely valuable for you. Imagine putting these huge robots in your factory which take up so much space. You need to put a fence around. Instead of 6 machines, you will be only be able to put 2 machines or 4 machines at max. But in case of UR robots, it can be fit into the space between 2 machines that you have in your factory. You just put it there, plug and play, and you're good to go.
मैंने ये देखा इस रोबो में, जैसे आप एक स्मार्टफोन यूज करते हैं आराम से, कोई परेशानी आपको नहीं होती है, उस तरह इस रोबो का यूज करेंगे, कोई परेशानी आपको नहीं होगी। ये एकदम स्मार्टफोन की तरह है। प्रोग्राम आपका इजी है और सेटअप भी इजी है और बहुत लेस टाइम में आप इसको आराम से सेटअप कर सकते हैं।
जब मैंने न्यू इंजीनियरिंग वर्क में ज्वाइन किया तो मुझे इस काम के बारे में कोई आइडिया नहीं था। मैं धीरे धीरे काम को सीखी, सिर्फ जॉब लगाती थी, निकालती थी, बस मुझे यही काम आता था। फिर उसके बाद मैंने यूनिवर्सल रोबो भी सीखी चलाना और ये मुझे चलाना बहुत अच्छा लगता है।
हम लोग अगर आज मान ली रोबोट में इन्वेस्ट करते हैं तो मैं आदमी को बेकार नहीं कर रहा हूँ, मैं उन लोगों से और अच्छा काम कर रहा हूँ, जैसे क्वालिटी, CMM, इंस्पेक्शन, उनको एजुकेट करना, इससे अच्छे काम में करना। आई कैन एक्सप्लोर मोर बिजनेस। करीब 40% हमारा ग्रोथ है। सपोज देर आर कंपोनेंट्स वर इन लैक्स, सो हमको बहुत सोचना पड़ता था कि हम 24 घंटा कैसे चलाएं, तो वो मैं चला पा रहा हूँ। तो ये हमारे लिए वाइबल भी है और प्रोडक्टिविटी भी हमारे हो रही है।
They are actually cobots, collaborative robots as you call them, which work side by side with my workforce on the shop floor.
हमारे जमशेदपुर में कम से कम भी 1000 SMEs फैक्ट्रीज हैं और मैं हर लोगों को जो कि इस इंडस्ट्री में हैं, मैं उनको एक ही रिक्वेस्ट करूंगा कि सब रोबो लगाएं। और रोबो लगाने के लिए सिर्फ कॉस्ट से डरे नहीं, हर आदमी को चाहिए कि वो इसका कंपैरेटिव कॉस्ट का कैलकुलेशन करे कि मैं क्या इन्वेस्ट कर रहा हूँ और मुझे इसका क्या रिटर्न है। और मैं अपने यहाँ देखा हूँ कि जो इन्वेस्टमेंट हम करते हैं उसका ROI बहुत अच्छा है। एक रोबो लगाने के बाद हमने 5 रोबो और लगाए और फ्यूचर में भी हम और लगाने की सोच रहे हैं। आप 10 अच्छे कंपोनेंट बना सकते हैं, 100 अच्छे कंपोनेंट्स बना सकते हैं, लेकिन आपको हज़ारों में और लाखों में अगर बनाना होगा तो बिना ऑटोमेशन और टेक्नोलॉजी के संभव नहीं है।
So I think that's a good example of how an SME used, take a look at how an FMCG company using it.
One of the key priorities for Pune factory as of now is being flexible and agile in terms of serving the market in real time.
On line number 27, which is one of the fastest line in my production unit, the end of line operation, the putting the boxes on the pallet, we were doing it manually.
Single operator doing the entire job of lifting 8,500 kgs of load every shift. Right now L'Oreal is war-footing and stepping up really hard onto the ergonomics part, and this was one of the major concerns which came from down the line.
When we did our ergonomic risk analysis, we found that it is a level 4 risk and we wanted to eliminate that risk.
UR10 we installed before 2 years. The purpose of this installation was automatic palletization. Before installation of this Cobot, we use a single pallet at a time for the palletization. Now, simultaneously we can use both pallets without stopping the line, where we have a 30-minute saving in every.
Scandinavia, one of Northern Europe's leading food companies. Atria produces vegetarian and gourmet products for convenience.
Volume down, and this time we're going to see an example of food processing. So actually, secondary packaging, you'll also see carton erection, those kind of things. Labeling. So these all cobots that you see there. So palletizing, let's see, I think carton erection will come up in a minute. And I think the beauty is the operator is right there with the robot, right? So you don't need to be fenced off in any way. So very minimal downtime, okay? No safety guarding required.
nasza fabryka od ponad 20 lat.
Just to show another example, Unilever in Poland, how they are using it in their factories. Once again, for case erection, in fact, they've got 6 robots here used for palletizing purposes. In the interest of time, I'm going to just go on here and show you that these are the different applications that you can do with this arm of yours, Cobot arm. Okay, machine tending is probably the biggest use, along with pick and place. But the robot is being used for assembly, as you saw on the Bajaj assembly line. It's used for quality inspection by putting a camera at the end here. Screw driving, injection molding, glue dispensing, packing and palletizing. So these are the typical applications that we do. And what I'm going to do now is request Aisha to run the second vote now, while I prepare to show you a demo of how to program this Cobot. So go ahead. So please take a few seconds to answer these questions. Which kind of applications do you have the need to do? Okay, I think that should be enough time. Can we have the results? Okay, so assembly is one of the biggest applications that people have. Gluing and dispensing, machine tending is a large one. Packaging and palletizing is large. Quality inspection is pretty big. Okay. And other. Good. So with this, hopefully you can see my screen now. And can you see the teach pendant? I just make a quick check. And the Cobot now. Can somebody confirm that you can see it?
Yes.
Okay. Very good. So this is the collaborative robot, the 6 degrees of freedom. And what you're seeing on the left-hand side is the teach pendant. And how easy or difficult is this to program? So you see the top, there's about 6 icons on the top. And program, it's an empty program right now. There's nothing in the program. So in a robot, typically I would do a move command. In move, there's a move J, move the joints in the most efficient manner. Or there's a move L, where I want to move from one location to the other linearly, calculate a straight line. Or a move P, so where let's say I'm doing dispensing of a glue, or I'm dispensing some paint, and I'm going on a curve. I want the process to be absolutely smooth. So then I would choose a move P. So that's how it would move. And move, I want to go to a waypoint, so a particular location. And let's say that this location is where I want to start from. Okay. All I can do is hold this little button out here. It's called the free drive button, and move the Cobot to a certain location. Okay. So by holding this this button here and moving the Cobot to a certain location, okay, I just turned the power off, excuse me, restarting it. The beauty of the Cobot is I don't really need to know the coordinates. You know, normally 6 degrees of freedom, I need 6 X, Y, Z, RX, RY, RZ to locate a certain point in space. But by just holding this free drive button, I can grab the robot and move it to here. Here's the location I want you to pick up a point from. Okay. So at this point, I'll say that I want to set the waypoint right here. This is the X, Y, Z coordinates. Same way, I'm going to set another waypoint, hold this, and maybe I take the object to that point, right? And set that waypoint at there. And finally, I do one last waypoint, number 3. Again, either I can move it with, and maybe that's the drop-off point, you know, or I'm holding it there for a camera. So set that waypoint, okay. And now I just want to test my program, okay. So I move the robot to the original point where I started from, and I say play, okay. And sure enough, you can see the program being executed, okay. It's going to waypoint number 1, waypoint number 2, waypoint number 3. It was that easy, okay. Just a matter of seconds to get a robot to move. It doesn't require any particular skills. Now, but maybe after this first waypoint, I wanted to do a wait, you know. So I wanted to wait for maybe 2 seconds, okay. And after waiting 2 seconds, I want to set an output. There's a PLC connected to it here. You see, if you can see here, there's a box, and this box actually has the control box that comes with the robot. It's got some inputs and outputs and analog inputs. It's also got the various communication channels. The communication channels are like Ethernet, and a Profinet, Modbus, etc. are all available in the controller. Okay. So here I want to say set a digital output number 3 to high. So maybe at that first position, I say wait for a second and then turn on an output. That output maybe closes the jaws of the gripper. Okay. Then I go to waypoint number 2. At that point, I wait for maybe another second, right? And finally, I go to waypoint 3. Again, do another wait for a second. But at that point, I want to set that same digital output number 3 to low. So I'm turning off the solenoid valve, right? So that's my program now. And I'm saying go run it and start from the first point, okay? And then I hear it say start, go ahead, okay? Okay. So now the robot is actually going to move from point 1 and it's waiting 2 seconds, the digital output turned on and now it's turned off. Now, how do I know that the output's turned on and off? I click this IO tab and sure enough on the right hand side, you can see the digital output number 3 just went off. Here, I'm enabling a digital output 3 came on, etc. See, so a very simple program, and you can actually see the program executing here. You can also see the graphics. You know, for example, if I actually want to see this without the robot around, I can actually put it in simulator mode and just run the graphics and see if it's doing what I want it to do, right? So in a matter of a few seconds, you have learned how to program a Cobot. All right, it's that simple. And there are more advanced commands. I can go to loops and sub-programs, a little bit more advanced programming as my programming gets more complex. I have templates wherein I can choose a palletizing wizard. So all I have to do is say the first point of the pallet, the last point of the pallet, and the pitch. And that's it. It will calculate all the different box positions for me, conveyor tracking, etc. So hopefully I've impressed upon you that this is not rocket science. This is something that you can teach your operator to handle, okay? So with that quick demo, I know it was very quick. We'll, excuse me a second. So I'm back here again and we'll take you through a last few slides. Okay, so we heard what you were interested in. So we'll try and show you maybe a few more videos. For example, top left shows you a pick and place. I'm handling glass out there, okay? The top middle, it actually shows the dispensing applications where glue is being dispensed very delicately on the windshield, you know, so that the sealant application. Top right is showing an inspection application where a camera is being held by the Cobot. It's looking at the side wall of the tire, then it's looking at the tread of the tire, then the other side wall. So instead of having multiple cameras, the Cobot is moving the inspection system to its right location. Bottom left, you see Jeff Bezos, the most richest man in the world, playing with gloves, haptic gloves, which are allowing him to control 2 robots. So let's say you're handling a COVID patient there, or you're handling radioactive material, or a minesweeper. This is how you could do that, right? So a lot of R&D type activities go on with Cobots. Bottom middle is some more standard. This is in a facility in Bangalore, where it's actually doing some production here. And a little more complex one on the bottom right, where it's working for Airbus. So Airbus has actually put it on a movable trolley, and this is a screw hopper. And from the DWG drawing of the wingtips, it actually goes and spots where do I need to put the screws in, and it goes and puts the screws completely autonomous. You know how many thousands of screws are there on an aircraft wing? So the R&D facility of Airbus has developed this application. Okay? So just to give you an idea, it can do very simple jobs. It can do very complex jobs. Okay? Top left actually shows you a laptop manufacturing facility where it's actually carrying the laptop, putting it in machines, working right next to operators. You know, so that's in a electronics shop. Top right actually shows a more commonplace application for us, okay, where the robot is actually doing the ironing of shirts while the operator does the folding. Or the bottom left, this is actually like a sanding application or a polishing application, etc. So very, very versatile what it can do, okay. And I think I've reached 5 o'clock, so what I should do is fast.
service.
We have many more examples. I'll show you this. Mr. Kejriwal talked about women empowerment. You see every picture here is a woman in India with a Cobot. She's programming it, she's using it. It could be in Jamshedpur, it could be in Madurai, it could be in Chennai, different places, right, around India. Manufacturers are making use of Cobots to augment their workforce with women. In fact, Rahul Bajaj has a vision of having 50% of his assembly line should be filled with women. Okay, so and he's very close to accomplishing that with the help of Cobots. Used in R&D centers like TCS, for example. This is their R&D center, and they have visitors from all over the globe. They have a robot, and they show how their next generation Industry 4.0 labs are going to look like. You know, so if any of you have R&D centers, we always recommend buy one of these because you have no idea what you can do with a Cobot until you try it yourself. That's what Bajaj did. They bought one robot. Next year, they bought 23 because they found out that, hey, we can do this application and that application, and all this is so easy to do. They got many ideas, right? So we always recommend if you have an R&D center, engineering house, whatever you call it, get one of these because your people know your applications much better than anybody else. They will be able to use this tool to improve your productivity, excuse me. Similar one at Mercedes-Benz where we're doing automatic parking. So this was posted by the CEO of Mercedes-Benz himself on his LinkedIn page. Okay. And there's a customer who 10 years ago bought our Cobot, is still using it. You know, there's a slightly different looking Cobot as you can see, but he's our first customer 10 years ago. He's still using it, you know. So we have a couple of programs called UR+. So if you want to select a particular camera, 2D camera, 3D camera, 2-jaw gripper, or this gripper, for example, which will allow you to measure your component while you pick it up, either from the ID or from the OD. There are many companies that make devices that fit with our Cobot. Okay, that is called UR+. It's something like a driver. You buy a HP printer, it somehow works, right? The driver is included, or it comes on a USB. Well, the driver for this device comes on a USB, plugs into our Cobot, and it works with our Cobot. Okay, so that's what UR+ is. There are about 250 different companies that have made grippers, that have made pneumatics, that have made, you know, cylinders to go up and down, 7th axis, many different things on UR+ to give you the flexibility of design. Finally, we have, if this was interesting to you, you want to start learning about this, go to our webpage, Universal Robots Education. There's an academy. And you can start learning. There's 9 modules free of cost. Do the test, you know, see if you've understood how to create a program, how to interact with external devices, you know, through I/O. How do I do my safety settings? Will this meet my packaging needs? You know, that kind of stuff. You can do all this. It's free of cost. You need more than that, give us a call. We can help you out with that. We have in-class training. Just a couple last slides on my company. MIT, again, Massachusetts Institute of Technology, placed us as one of the smartest companies in the globe, along with people like Tesla Motors and IBM and, you know, Microsoft and Apple, right? You won't see a KUKA here, you won't see a Yaskawa, you won't see a Fanuc. That's old technology, right? That's robots. This is collaborative robots, and you need smart technologies to be successful in the future. Okay. So with that, the last video, absolutely, is
this or complicated platforms
to do this job. Would you like to do this job up
in a
on
high-risk
windmill,
environment?
servicing the windmill because it's got cracks and I need to weld it and I need to do this. Well, some smart engineer said, this is a tool, a Cobot. I'm going to take this tool, put it on some ropes, and I put a camera there. I can now see which part of the blade needs maintenance. And if I need to weld, I pull out a welding gun, I do the welding. If one of the blowholes is clogged, I pull out a screwdriver and I screw through that hole which is clogged, and this guy is remotely controlling it instead of sitting on the blade. Okay? So extremely intelligent use just by having it in the hands of engineers, because they know your product, they know your process better than anybody. Okay, and they will be able to figure out how to make use of this technology. Think of a Cobot as part of your toolbox. Okay, just like you have a hammer and you have a wrench and you have a drill, the Cobot is the next generation of tools. Okay, it enables your engineers to do much smarter work on your shop floor. Okay, and that's my last slide. My email address is there, phone number is there, etc. If you would like to get a hold of us, and we will like to now open the floor out for questions. Over to you, Sanjay.
Thank you, Pradeep. Thank you, Navneet. I think we can straight away go to Q&A. We have been getting so many questions. Maybe some of the selected ones I'll choose. There are many questions from various industries, which are coming in, right from textile to fabrication to welding, and a lot many people are asking, we need more details, more details. Probably we'll send them offline. I have a question which is on the payload side. Why do we have a restrictions on cobots for the payload restrictions for the cobot?
Okay, so understand that a cobot, the very definition of a cobot is collaborative robot. It has to be safe to operate next to a human being. So let's say I put a 50-kilogram load on a cobot, right? We could easily make the motors bigger and make that bigger, but now it's no longer safe. That load can fall on the person and crush him, correct? So it's very important when you talk collaborative robots that it be safe to operate next to the human being, right? So for that reason, in fact, we didn't even have 16 kilograms until last year. So we only did till 10 kilograms, and we feel that the majority of the safe applications where a human and robot can work together as a cobot should be within that 10 kilograms payload, now 16 kilograms. Okay.
Thank you. Thank you. I think it must have been addressed to the respective audience. There's a question from, from manufacturing in general. So what are the benefits of a cobot vis-a-vis to a traditional robot?
I'll let Mr. Kejriwal, maybe he can, because he's a user of it, maybe why wouldn't they have chosen a robot instead of a cobot in that case? So let's see his view on that.
So I think first is the Cobot is very safe to work with humans, and the second is that it's very flexible and can be repurposed. So I like the last slide which Mr. Pradeep showed, where it's like a toolbox. So you buy a Cobot, you buy with some specific application in mind, but then later on, if your requirements change, if I have to redesign my production line, then I can easily repurpose that to do something else, something different. So your investment is still protected. And the first reason was, of course, it's designed for human collaboration.
Right.
Very safe, as an assistant to humans. So that partial automation that you mentioned is a very important way to, very interesting way to optimize your automation investment. You don't have to automate everything, which you saw in one of the cosmetic packaging line. You do the part of the work and let the human do the other part, and you can decide which one you want to allocate to the Cobot as an assistant to have the best experience for the human. So I think these are the two main things I think about between a robot. Robots you've seen, in traditional automobile industry, you typically always see videos on, vehicle painting being done by traditional robots, or welding, which are very heavy. They are typically fenced off. They require a lot of space, and they are inflexible. They are basically, designed with one specific application in mind.
Yeah, I'd like to add, Mr. Kejriwal. In fact, in Chennai itself, where you are, there's other manufacturers, like Royal Enfield, who've actually taken the Cobot and mounted it up on the ceiling. So for them, it was important to have a clutter-free shop floor. So, when you have a heavy robot, then you have a huge structure to support it, whereas Cobot is pretty lightweight. So it's very easy to mount on top and keep your shop floor clean and free. So there are many reasons people use Cobots, and this probably are some of the main ones. Sanjay,
thank you, Navneet. Thank you, Pradeep. I have one more question, which is from our audience at Indy. He is from an apparel industry. So he's telling by using Cobots how it can help in the manufacturing process of an apparel industry.
So there are many applications of cobots in apparels. In fact, there's almost no sphere that it's not penetrated. I didn't talk about it, but you have cobots today in bartending, in hotels, they're making omelets, you know, in breakfast buffets today, they're actually in cooking. So there's a kitchen in Mumbai, sorry, that is using cobots, you know, one of these cloud kitchens, they call it. So it's got enormous uses in multiple industries. So yes, in textiles, we have a company that has made what they call a Cobot, which actually helps with the sewing application. I'm trying to think what exactly was the application. Oh yeah, jean scraping. You know, where you have the jeans and the color of the jean is removed. You know, you pay big money for that, where they're torn and jeans color is removed. It's called jean scraping. So our cobots have got this wheel which actually removes the paint of the jeans. You know, I've seen it used in that application. And there are several others. If you can get back with us, it's not coming to my mind, but we have videos on textiles that we can share with you. Oh, by the way, in Sri Lanka, the large textile companies, you know, the really large guys who are actually making the clothes for Indian cricketers and all that stuff, these are big companies, have all bought it for their R&D purposes. So many times they will buy it and we have no clue what they're doing with it because they're planning their next generation of manufacturing. We help them run the Cobot, but we don't know what they're doing with it. So very common use is in innovation centers in textiles.
Thank you, Pradeep. I think the next question is for Mr. Navneet. Because as in his insight, he gave his experience using the UR cobots in his factory. The question is how long you have been using the UR cobots and what are the advantages, especially it has given you in your production, keeping the current competitive time in mind.
So I think we've had this collaborative robot from UR almost more than 3 years. So it's in a very high volume manufacturing line where every minute you have 3 or 4 units flowing through that production line. So you can imagine how many cycles that Cobot has gone through in 3 years, more than 1 million. And it's very reliable. It hasn't had any problem. To your second question, what advantage? Yeah, of course, at the point when we were introducing this, we had some anticipation of some benefits coming out of that, and we have actually been fortunate to have attained those benefits. Productivity improvement was one. Second is the making the job easier for humans. So no longer a human has to lift a computer from the conveyor line to put the cushion, the end caps on the 2 edges to put it in the box. So that all that pick and place, that difficult part of that work has been transferred over to that machine. Very reliable and very dependable machine. So that has been the benefit. Now the task has become easier, and in the current COVID situation, we had to rearrange the humans in the production line to allow more distance between every 2 individuals. But this particular task, the way it was originally designed before the Cobot, there were 2 people very close to each other. One was lifting the unit, the other was putting the end cushions and then dropping it in the box. So there were 2 humans which couldn't be separated because the nature of the task was such. But in the current COVID, we are fortunate that we have this Cobot already deployed. So this task can be done by 1 person without any fear of COVID transmission. So this has been very beneficial in these current times.
Yeah, I'd just like to add to that. We say that the cobots are ideal for the 5 Ds in manufacturing. What are the 5 Ds? Jobs that are dull, okay, repetitive jobs, dirty. Humans don't want to do that job. Dangerous, so back-breaking job. We saw that in L'Oreal. Difficult. So cobots with that 360-degree plus or minus can actually go and contort their ways much more than a human being can do, and very difficult insertions into a machine and retrievals can be done. So dull, dirty, dangerous, difficult, and where distancing is required is the number 5. So 5 Ds is what cobots really help you, where distancing being the last one.
I think the next question is very similar what Pradeep has just spoken. Again, it may be from the automotive point of view. The application, can cobots be used for welding, fabrication, or painting in a vehicle assembly unit?
The answer is yes. Robots are being used in welding applications. Whoever asked that question, do get with us. There's many types of welding, right? There's TIG welding, MIG welding, there's arc welding, etc. So we've got huge amounts of data on each one of them. So please get back with us. Typically, what we see a cobot user using, welding robots are available dime a dozen if you go to the market, right? And they're optimized for certain welding. Where a cobot is different from those kind of welding robots is, it can also at the same time do your glue dispensing, or it can do your nut running. So I can have multiple tools where I can pick up a welding gun where I need to, right? This is where the benefit of a cobot comes in, right? That whole concept of a tool, not just if you're planning to use it for simple welding. There are many welding robots that will probably do a better job, right? But you need more than that. You need to do machine tending or something else with it. Then you cannot beat a cobot for that task.
Yeah, this was Jai Ganesh Swaminathan.
Yeah.
There's a question, one more. Which are the popular industry in India for cobots, where it can be used?
Okay, so in India, the automotive industry is by far the largest user, right? But very, very rapidly, and that is auto components, manufacturers, two-wheelers. We're doing a lot of work with two-wheeler companies, because once again, the part weight, it was 10 kilograms only till last year. So we couldn't go up to 16, now we can. But these parts were more conducive for two-wheelers. Now with 16 kgs, we're seeing a lot more four-wheeler applications coming in. But the second industry that we're doing really well now is the FMCG industry. FMCG is the fast-moving consumer goods for primary packaging of boxes, so the large companies in India, which are FMCG, I think you all know the names, you use them on a daily basis. They've started using a lot of cobots. The industry that is really rapidly catching up is Mr. Kejriwal's, which is the electronic space. Okay, so in China, for example, our largest business volume is not with automotive, it's with electronics. Not so in India. In India, it's automotive the highest, electronics is third. But when you're seeing the Wistrons coming in and you're seeing all these different electronic Samsung, etc., coming in, they have tremendous usage of robots. For example, for nut running is very common applications in the electronic space and the cell phone companies, etc. So I see that probably being one of our fastest growing spaces now. I didn't talk about Continental. Continental is probably one of our largest customers globally, not in India, but globally. And they've used over 1,000 cobots, and they're into the electronic space and automotive electronics, if you would.
Thank you, Pradeep. I think we have one more very interesting question. How the cobots are, aligned with currently we are into the Industry 4.0 era. How you are aligning the cobots for Industry 4 when it comes to the smart factory?
Okay, so the Cobot is not a separate device. It kind of integrates into your factory, right? I don't think I spent enough time on it, I'm sorry, but it's got Ethernet communication, it's got TCP/IP sockets communication, it's got Profinet communication, and it's got Modbus, right? So whatever PLC you have in your plant or whatever network you have, the PLC can connect to that, the Cobot can connect to that and be part of your overall plant infrastructure, right? So if you, for example, have multiple cobots in your plant, we can very easily show you how to, let's say I have 20 cobots. I can sit in my maintenance shop and see, oh, robot number 18, joint number 3 is going over temperature. It's just very standard. You just got to do nothing but plug your Ethernet cable into it and you got that data. Okay, so it's completely Industry 4.0 enabled.
Thank you. Probably I'll take one more question before we end up the session. This is for Mr. Navneet. One of the audience is saying, as you are from the electronic manufacturing industry, what is that USP you think the Cobot is really giving us the best service in terms of the production and in terms of the downtime of the machine, if there is any downtime?
So in my experience, we have had literally zero downtime with the Cobot solution that we have implemented. So I'm not clear. What was your other question?
The question was from the electronics manufacturing point of view. What is that USP you can suggest for other who are into the similar business, similar manufacturing, electronic components?
So I have seen Cobots being deployed in other electronics manufacturing plants as well. So as I mentioned a couple of use cases in our own plant here, but in electronics, as Mr. Pradeep also mentioned, there's a huge potential right from, surface mount technology line, SMT lines, where you have to mount place the boards, the bare boards on the SMT lines. And then at times you have to flip the boards. And then, so there's a lot of potential in the component or the sub-assembly areas. Then the final product system assembly, that's what we do here in our plant. There's opportunity in some of the assembly tasks, some in packing, palletizing, so pick and place, connections, so installing components. So you have to develop. Some of these are already, you can look at some catalog of use cases which UR already has, but you can be creative and you can create new solutions. Electronics is a huge opportunity simply because electronics is light assembly. The components are small and most of them are less than a kilo. And the system itself, if you're making a set-top box or a medical device, which is small form factor, you can use the 10 kilo Cobot or a 5 kilo Cobot, and if you have production facilities also space constrained, you can either mount it on the floor or you hang it from the ceiling. So it gives you a lot of flexibility. So there's a lot of advantages in Cobot, but you can be either creative or you can select from use cases which have already been developed in the industry.
Yeah, thanks for that. And actually, I had a couple of videos that I wanted to show, but due to time, I actually didn't show them. So whoever asked that question on electronics, please get back with us. I'll share the videos offline. So I mean, chip insertion is there. There's one case story we have of 2 million PCBs being packaged every year by one company. And then of course, like Mr. Kejriwal mentioned, our parent company, Universal Robots' parent company, is called Teradyne. Teradyne does nothing but electronic test equipment. So they use a lot of Cobots for exactly what he talked about, taking the boards, flipping them in a machine for inspection, soldering continuity tests, all kinds of things like that. So do get with us. We'll share you more detail.
Sure. I think we have many more questions, but due to the time constraint, I just picked up the chosen ones, which needed attention from our respected speakers. To sum it up, I think we had a fabulous discussion, and Pradeep really took us as an eye-opener for various SMEs and sectors, right from the dal manufacturing in Chennai and then the various other SME units where the workforce was using the UR cobots. It was very useful, I think, for audience also today to see how cobots can be used in various industrial applications, right from automotive to healthcare to masala company, to put, across the windshield, and how this collaboration can be done along with the humans. Because as you rightly said, we are here on the cobots. Cobot is a collaboration with humans and cobots. How we can put it together. Thank you, Pradeep, for such an insightful and learning session. In fact, for me as an individual, I learned a lot of things today about the cobots, and I'm sure audience also must have taken kind notes for this. Navneet also, I think he was the best customer who has put honestly all the usage and applications of the Cobot, and he has used on the two themes, partial automation and flexible automation, and then he put it into two pillars of digitalization and smart automation, which he connected in terms of when it comes to getting the best application for a Cobot. I think it was well connected with the audience. What I could see, a very eye opener from the application point of view. And he used the word "UR are the reliable machines," which really should give a thumbs up. Being online and saying the best part of USPs of the UR. And they have been using it for the last 3 years with no downtime, which is highly appreciable in terms of the USP of the product. And I'm sure our audience who are connected with us today have taken a lot of learning, lot of knowledge, and they must have noted down all the points. We had interesting audience from various industries, from apparel, textile to glass to automotive. Various industries were present with us, from the FMCG also, few of them. I think it was quite interesting to know. I should really thank you on behalf of ITP Manufacturing today for being part of this session, especially Mr. Pradeep and Mr. Navneet taking your time out to be a part of this webinar session. And we are looking forward to have some more interesting sessions in the future course of time for our audience. The recording of this webinar will be available on our YouTube channel, which we will share with all the people and all the attendees and speakers. Thank you very much once again for your time taking today for this webinar. Thank you very much.
Thanks, everyone. Thank you. Thanks to KJL particularly. Thank you.
Thank you.